Welcome to BTEC Revision. In today's lesson, we're looking at gravitational potential energy. By the end, we should be able to calculate the gravitational potential energy of a system. The gravitational potential energy of an object is entirely dependent upon the mass and the height. The higher you raise an object, the more gravitational potential energy it gains. And if the object has gravitational potential energy and you increase its mass, then it will also gain more gravitational potential energy. Gravitational potential energy can be calculated using this equation, which is equal to mass times gravity times height. The short form GPE, which stands for gravitational potential energy, M stands for mass, G for gravity, and H for height. The units are joules for gravitational potential energy, mass is measured in kilograms, and height is measured in meters. So we can rearrange this equation to work out the unit for gravity. If we rearrange this, we have G equals GPE over M times height. Looking at the units, that's joules per kilogram, meters. So we can say the unit for gravity is joules per kilogram, meters. And if you remember our equation for work done, which is force times distance moved, rearranging this for work over distance equals force. Looking at the units, that's newtons equals joules per meter. So we can replace joules per meter here with newtons per kilogram, which is also another unit for gravity. Gravity also has another unit, which is the unit for acceleration. And that, if you remember from previous lessons, is meters per second squared. So you can see gravity here has many units, and it's a very important value. Here on Earth, it is equal to 9.8, which is what you need to know for your specification. And the units, we can choose any of these three here. So we'll go with newtons per kilogram, because this is the more commonly used unit. On the moon, gravity's value would change. It is less, it's 1.6 newtons per kilogram. And we can write this as G, lowercase m, to represent gravity on the moon. Gravity on the Earth, we'll write as G, lowercase e, equals 9.8. Now, let's look at an example. An object with a mass 20 kilograms is placed on a shelf that is 5 meters above the ground. Calculate the gravitational potential energy of the object. We will start by writing down the equation GPE equals mgh. And we are going to assume this is here on Earth. G is equal to 9.8 newtons per kilogram. Plugging in the values, m is 20 kilograms times g, which is 9.8, times a height of 5. And this gives us a value of 980 joules. So what does this mean? We have an object. Its mass is 20 kilograms. We place it up high from the ground on a shelf. So this object has now gained 980 joules of energy. And this can be transferred into other forms. And you will learn more about this next lesson. So, for example, if we take this ball and it rolls and drops, it has gravitational potential energy at the top. And as it's falling, it's going to gain kinetic energy. It's getting faster and faster. And before it hits the ground, it's going to have maximum kinetic energy. So the gravitational potential energy, which is 980, is going to be transferred into kinetic, which is also going to be 980 joules. Pause the video here and attempt this exam question. An object gains a gravitational potential energy of 1 kilojoule. Calculate the mass of the object in grams if it is placed on a shelf 8 meters above the ground. Now, in order to work out this question, the question is asking for the mass. And if we note, we have the value of energy, gravitational potential energy being 1 kilojoules. So first thing we should do is convert that into joules. We know a kilo is 1,000. So the GPE is equal to 1,000 joules. Next, the distance, 8 meters, that's fine. And now we can work out the questions, which is asking for mass. If we write down the equation, GPE equals mass times gravity times height. Now we can rearrange for m, divide both sides by g and h, and that will give us m equals GPE divided by GH. Plugging in our values, we have 1,000 joules divided by G, which is 9.8, and the height is 8 meters. And that would give us a value of 12.76 joules to 4 significant figures. And that's the end of the lesson. If you would like to boost your grades, try the quiz questions at btechrevision.com, where there's lots more resources. See you next lesson.